So I'm here at the European Geosciences Union Conference 2025 on the terrace on a beautiful day in Vienna with a fascinating young oceanographer, ocean science researcher from Bangor University in the UK, who has just given an interesting talk based on a paper that was published in the Journal of, you tell me, Sophie.
Geophysical research, oceans.
Sophie Ward, and it's about carbon sequestration in ancient subsurface mud deposits in seas. Primarily, your research is based on three mud deposits in and around the UK. Let me put it like that. Is that correct? In the North Sea area and the Irish Sea. So, give us a gist of the abstract from your paper and your talk.
Yeah, sure. So what I'm interested in are offshore muddy deposits. A lot of organic carbon. Carbon is stored up in these offshore muds, a really important part of the global carbon cycle. Now, these carbon stocks and the carbon stores, it's really important that we look after and manage them properly. To do that, what we need to do is understand the dynamics of the carbon and the dynamics of the mud. And what I like to do is use ocean models to simulate and model how the mud might have got there, how it got there, when it got there, and that will help inform our mapping efforts to map where the muds are, and to better understand carbon storage restoration efforts and offshore management practices.
So how does these mud deposits stack up in terms of other carbon sequestration that we find, for instance, old growth forests, the ocean itself? How important are these, or do we even know at this point how important they are?
I think we absolutely are acknowledging as a community how important offshore carbon storage is. There's huge efforts globally at the moment to better understand how much carbon is stored up in global shelf seas. These very localized case studies are a really important part of the bigger picture. There have been various efforts to quantify the global carbon stocks in offshore sediments, but there's a lot of work to be done. And it's what's fascinating about the field is that it's so multidisciplinary. There are all sorts of scientists working within this field of offshore carbon storage.
And you mentioned particularly the Flayden ground, am I pronouncing that correct? Which is a offshore deposits of mud. Can you give us a bit of the history behind the Flayden ground? When do you think it began collecting mud, and what your recent models are telling us about it? And I think you say it's now no longer collecting mud, so it's still sequestering carbon, but it's a relic deposit. Is that right?
So the Flayden ground is a really interesting case study because geologists have known for a long time that it's not currently accumulating new sediment. So it's a big muddy area in the North Sea. It's a known fishing site, so there are disturbances to the muddy deposits there, and this disturbance may be affecting the way that carbon is stored in the muddy deposits. And what's interesting about it is that the Flayden ground, it looks like the muddy deposit of the Flayden ground developed a long time ago, and we can actually use ocean models like the ones that I use to help explain how the mud was deposited, when it was deposited, and we can use those as a backup to the geological data. And this is really such an interesting field because it's not always possible to go out and collect new data. It's a really expensive, timely research endeavor.
And why is that? Tell us why that is. You told me in the interview just now.
Yeah, to collect offshore data, we require ships, we require vessel time, you need good weather, right? You need a lot of specialist equipment, and then even once you've collected the samples, there's a lot of post-processing required.
And these are drilling sedimentary cores, correct?
Yeah, and the drilling of the cores is really important for this aspect, the angle that I really enjoy, which is the going back in time, because those muddy deposits, if they've been there for a long time, they're really deep down, they could be meters deep in these offshore muddy deposits. And what I like about the Flayden ground is that it's really different to these other big muddy deposits that we know about on for example, the Western Irish Sea mud belt and the Celtic Deep that I looked at, because what we know from the sediment data, and we know that because we tested this methodology in areas where we do have data, is that Celtic Deep and the Western Irish Sea mudbelt are much more recent muddy deposits,
Mhm.
and that can be simulated and that can be explained by the changes in the hydrodynamics and the changes in the ocean flow, essentially, of the area. And that's what I use my ocean models for, is helping to explain when, how, and these muddy deposits might have been formed.
So old growth forests kind of get all the headlines in terms of sequestering carbon, if I'm not incorrect. The mud deposits are less sexy.
Right.
Carbon,
Yeah.
a method of carbon sequestration, correct? But I mean, they're important, but they're probably not as appreciated as they should be. But you were telling me, am I wrong in that?
Well, I suppose it's appreciated in my field.
Right.
We appreciate the offshore mud, and
Uh,
you're right that I think that people can identify better with news stories that they can see, right? So they know that the trees are there, they know that those sequester carbon. It's been talked about for a really long time. And what we would love to do as a science community is is to continue communicating how important these offshore muddy deposits are, what the offshore carbon stores are, how we need to be protecting them, managing them appropriately. They're a really important part of our global carbon cycle.
And the biggest threat currently is probably fishing, trawling for these shrimp on the sea bottom. Is that right?
In the sites that I was looking at, I think that's a really big issue, and I think there's a lot of effort at the moment in trying to quantify those effects. I think it's really important that we understand exactly what's going on when these muddy deposits are trawled, and there's a lot of effort around better understanding and quantifying those potential efforts for the carbon that is stored and locked up in these muddy deposits.
But the amazing thing that you told me, that these deposits could probably go back to thousands of years, 10,000 years maybe, 12,000 years to the last glacial maximum. And then you think this fladen ground probably stopped collecting mud maybe 4,000 or 5,000 years ago. And you were telling me, do you know why?
We think that what happened with the flading ground is that essentially the sediment source, so the input of sediments or fine sediments to that region, will have stopped as the shelf seas changed as the melting of the ice sheets occurred. The shelf seas were flooded,
Right.
and the flading ground in that area was largely established by several thousand years ago, and the hydrodynamics there have not changed much in that time, and it's been quite a tidally quiescent, so quite a calm area tidally for thousands of years. And that's why when there was a muddy source, a source of fine sediments, they were allowed to accumulate, and they've been allowed to stay. And I think that an appreciation of the fact that it's old carbon that's been locked up for a really long time is really important in terms of management strategies, because even if we completely protected that area, it will not likely be sequestering much new carbon in comparison to these other areas which are still actively accumulating a lot of fine sediments and organic carbon, like the Western Irish Sea mudbelt, for example.
So Sophie Ward, the oceanographer, you go by ocean scientist, I think.
That'll
Is that
do,
correct?
yeah.
Okay. At Bangor University in the UK. Thank you so much for your time. Fascinating subject, and good luck with your future research.